All right. Hello. Um, Mr. Christensen here. And I'm going to take you through the rules of exponents. You should have this in your possession, these guided notes. And so if you need to, you can pause this while you make sure you have what you need, and then we're going to get started. Okay, some vocabulary to be aware of with rules of exponents. Number, right? That should be an easy one. A variable like x or y. And product of a number and one or more variables. So that's when you're multiplying, like this one, multiplying a number and, in this case, two variables together. As far as the exponent itself and what that's made of, we have the base, which is the actual number that the exponent is being used for, right? So in this case, 5 to the second power, that means if I was going to write that out, it would be 5 times 5, right? So we have the exponent and we have the base. All right. And, sometimes people call that exponent a power, like 5 raised to the power of 2. And, that's perfectly fine to do. So let's look at the product of powers. You can see it right there. A to the m times a to the n equals the a times to the m plus n. So what are we noticing? We're noticing that we're multiplying two numbers or more with the same base. And when you do that, you add the exponents. So looking at 5 to the second times 5 to the sixth, right, that's going to be 5 to the 2 plus 6, which is 5 to the 8th. Now, if you want to see why that is, because some people would say, well, why aren't we just multiplying 2 times 6 when it's multiplication? Well, here's why. All right, 5 to the second is 5 times 5. 5 to the 6 is 5 times 5 times 5 times 5 times 5 times 5. How many 5s are there? 1, 2, 3, 4, 5, 6, 7, 8. Us, right? 5 to the 8th. Okay, so then we have y to the 4th times y to the 3rd times y, right? So that's y to the 4 plus 3 plus 1. Remembering that when there's not an exponent written, it does have an exponent of 1. You can write the 1 if you need to, and you can always use it just like I did here, and that is going to be y to the 8th power. Then we have this next one. We got two factors, right? Factors are generally surrounded by, when they have multiple parts, they're surrounded by parentheses. So in this case, I have 7y to the 5th times 6y, right? And, just keep in mind, we're just going to take, right, 7 times 6 and then times y to the 5th times y to the 1st, right? So this is going to be 42 y to the 6th power. Hopefully everybody's with me on that. Let's take a minute, maybe pause this right now, and as soon as we take a look at this problem, inside parentheses, -3 times x squared times y to the 7th, and then times 5 times x times y to the 6th. So pause now. Take a couple minutes to do this. Okay, so, right, we're going to have -3 times 5, right? I'm just going to write the like terms next to each other. Well, not, that's actually a mistake to say that, because these aren't like terms necessarily. X squared is not a like term with x, because like terms have the same exponent in addition to the same variable. And that's a term we use when we're going to add them together, right, or subtract them. Y to the 7th times y to the 6th. That's a 7. It looks a little like 3. Okay, so I've got negative 15 x cubed y to the 13th. Okay, there you go. Let's move on to the next one. Quotient of powers. So this is, instead of multiplying our bases, we're dividing the bases. And because we're dividing the bases, we're going to subtract the exponents. And we're always going to subtract the, well, I want us to start out doing it the same way every time. Bottom from the top. So if I have y here, y to the 6th divided by y to the 1st, so y to the 6th, right, divided by y to the 1st, which is y to the 6 minus 1, which is y to the 5th. Now, why is that? Why, oh why? Well, let's look. Y to the 6th. A little sloppy, but that's okay. And then divided by y. And what do I have then? I can take one of these y's, the y below, and one of the y's above, and cross them out because they're equal to 1, right? And that leaves me with 5 of them. So there we go. Now, so 6 to the 13th divided by 6 to the 2nd. So 6 to the 13 minus 6 to the 2nd, which is 6 to the 11th. And if you wanted to check on something like this and make sure it actually is true, that if you figure out what 6 to the 13th is, right, divide that by 6 to the 2nd, figure out what 6 to the 2nd is, which is 36, you are going to get whatever 6 to the 11th is. All right, so, but you can test it and check it yourself. Now, I've got here, I've got a fraction 10 over 15, right? And so 10, they have common factors of 5. So I'm going to cross out, I'm going to divide both those by 5, and I'm going to get 2 thirds. So I'm going to have 2 thirds. All right. And then a to the 7th divided by a to the 5th is a to the 2nd. And b to the 9th divided by b to the 9th, well, anything divided by itself is 1, right? B to the 9th divided by b to the 9th is b to the 0. Anything to the 0 power is 1. We don't need to write a 1. It's assumed it's there. Okay, and there you have that. So that's quotient of powers. So we have the 0 exponent. I was just talking about that, right? Any non-zero number with an exponent of 0 is equivalent to 1. All right. So you notice what it says, non-zero number. So that means that 0 to the 0 power, well, we'll look at that and see what that is. I think there's some disagreement. But anyway, we've got a to the 2nd divided by a to the 2nd. Well, first, let's just take it and write out 8 times 8 over 8 times 8, right? And when I cross them off, 8 divided by 8 is 1. 8 divided by 8 is 1. So I have 1 over 1, which is 1. Now, if I follow the rules that we just did up there, the quotient rule, right? That's 8 to the 2 minus 2, which is 8 to the 0. And so that is how you show that 8 to the 0 is equal to 1. All right, this next one, we have negative 3x plus 7 all raised to the 0 power. And because it's all raised to the 0 power, that 0 gets applied to all the terms in here, and therefore this is equal to 1. And I have 8x to the 0 plus 5. Well, x0 is 1, so this is 8 times 1, so it's 8 plus 5, right? 13. All right. Let's talk about negative exponents. Well, I want to go back. Oh yeah, this is actually what I want to talk about. So if a non-zero number a is raised to a negative exponent, place the power in the denominator to rewrite the power with a positive exponent. So to rewrite it with a positive exponent. So I'm going to kind of change it a little bit. I'm going to say put the base in the denominator if that's where, if you start with this as a to the negative n, right, it's not a fraction, then we move that whole thing to the denominator and make the exponent positive. So here then, let's look at how this can happen. If I have b to the second divided by b to the fifth, I get b to the 2 minus 5, right, which is b to the negative third. Sorry, why did I write 5? B to the negative third. Okay, so I have b to the negative third, which is also 1 over b to the third. Now let's just look at this second. B times b divided by b times b times b times b times b, right? So what do I have then? I've got two sets that turn into 1. B divided by b is 1. B divided by b is 1. I write a 1 up here. You can't just have a 0. And so this is 1, and there's 3 b's. That's 1 over b cubed. Okay. So I don't know if you have any questions about that, but that's how it works. 2 to the negative third, 1 over 2 to the third power, right? Negative 3 to the negative third, all right? 1 over negative 3 to the third power. Okay? Let's look at power of a power. Right, that means I'm taking something inside parentheses, and and it may already have an exponent on it, and I'm putting an exponent on the outside of the parentheses too. And so power of it, when you raise a power to a power, you multiply the exponents. I know that's so unlike product, right? The power of a product, okay, or the product rule, excuse me, unlike the product rule where that very first one where we would add, right, our exponents, here that's different. We're going to multiply the exponents. So x to the second to the 8th, right? So that's x to the 16th. Now, let's just talk about it a second. What's x to the second? X times x. Okay. And then to the 8th. So that means that I'm raising all of that. I'm going to multiply 8 times. So this is x times x. X times x. So I'm writing x times x 8 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 5, 6, 7, 8. and count them, there's 16 of them. Okay. Now, on this next example, it's important to note that rules of working with negatives, multiplying negatives, okay, do apply. So if we look at this, we have y to the negative third to the negative fourth. So I'm going to multiply those together. I'm going to get a positive, right? And so I'm going to get y to the 12th. Now, let's just look at it for a second and keep in mind the rule, right? The quotient, not the quotient rule, the rule of negative exponents, okay? Which says, going back up here, right, that we're going to place the power in the denominator to rewrite the power with a positive exponent. So over here, first thing I'm going to do is deal with negative 4, right? So I put it in the denominator. I move it to the denominator because it's negative. And I'm going to right? So y to the negative third, whoops, I don't know why I made that line so long. Y to the negative third to the fourth, okay? And if I do that multiplication, I get y to 1 over y to the negative 12th, which in turn goes back up here. So you're just skipping some steps. You're just saying, oh, two negatives multiplied together is a positive. You don't have to do all this other stuff. Power of a product. So if it's important to notice that if you have a power written out in parentheses, it applies to everything on the inside. Okay, not just a few things, everything. So applies to the 4 here, applies to the x to the third, applies to the x, and it applies to the z. Okay, so this is going to be 4 to the third, x to the ninth, y to the third, z to the third. And you can take it further if you're asked to figure out what 4 to the third is. You can do that, right? Pretty easy to do on a calculator or open Desmos and do it on a Desmos calculator. All right. 4 to the third, 4 times 4 is 16, right? Times 4 is 64. So, all right. So this next one, I've got a negative exponent, so I'm going to apply it again to each of the factors in here. So 7 to the negative second, x to the negative second, and then y to the positive second, right? So this becomes y to the second over 7 to the second, x to the second. And again, if you're supposed to take the 7 to the second, find out what that is. It's 49. So you could write it as 49xy squared over 49x squared. Okay. And this example, right? Again, I'm going to pause this for a second. I forgot to do that on some others. So we're going to pause while you see if you can work this one out. All right. 6 to the negative second, x to the 12th, y to the 14th, right? We're multiplying by 0, so it's still 0. So z to the 0 is 1, right? Z to the 0 is 1. We're not going to write that in our final answer. So I've got x to the 12th, y to the 14th, over 6 to the 2nd, or you could write 36. Okay, and when we're dividing, we have division, and there's parentheses around it, and there's stuff on the and an exponent on the outside. We treat this the same way. We're going to apply the exponent to each part of the division problem. So here, 3 to this is 3 to the 2nd over 5 to the 2nd. And if I wanted to, then I could take that and simplify it further, right? 9 over 25. All right. Looking at this one directly off to the right of that, right? I have 2 to the 2nd. And you notice I am writing out every time, mostly because it's easy to make a mistake or to miss something. So you want to write it out if possible. A to the 10th divided by b to the 14th, right? 2 to the 2nd is 4, so you could make that 4 if you want to. All right. Let's pause for a second. You do the next one right here. Do that one. And what the heck, do this other one too. I'll give you a few minutes to work on that. Okay, we're back. And so what do I have? I have 3 to the 3rd, a to the negative 12 over b to the 21st. And so this is actually 3 to the 3rd. I'm going to say that's 27, which is what it is. 27 over a to the 12th, b to the 21st. And this other one, right, we've got a to the 12th, b to the 30th, over c to the 66th power. All good. All right. So that is the rules of exponents. I hope that you're able to watch this whole thing and that you get everything filled out properly. Okay. Thank you, guys.